Okay, we're kind of finishing up unit 1 here, just doing a little more advanced with these equations. So this is going to be using both kinematic equations for lesson 7. By both, this is the two I mean. Going back to this one, Vf equals V0 plus AT. Your final velocity is your initial velocity plus the acceleration times time. And then that position or that displacement equation, remember x of t, you said it was x0 plus the V0t plus 1/2 AT squared. So for a lot of these problems, you're going to have to use both of these equations. In other words, kind of solve one and then plug into the other. Okay, but other than that, it's similar. But I do have a system of drawing these out. If you just stick with this system, should make your life easy. Okay, so an object is dropped from 40 meters from a 40-meter tall building. What's the velocity when it hits the ground? Okay, so you might be tempted to just start trying to plug numbers in and divide by 9.8 and all this stuff, but really you need to think really systematically. So draw it out. We're concerned about the starting and the ending on when we draw it out. Okay, so here's the starting, here's the ending. Okay, here's the things you want to put on all your drawings, these variables. If you do this, it's pretty systematic and you should be able to get all the answers. Okay, you got x0 and you got V0. That's at the starting. Okay, at the end, you've got your x of t, in other words, your position at the end. At the ending time, you've got your Vf, which is your final velocity. And you also have your time. Okay, so if you always set it up with those two at the beginning and these three at the end, you should be able to go pretty easily from there. Now you just got to put the stuff in. 40-meter tall building. That's actually my beginning position, 40 meters. Assuming that this is 0 meters. Okay, so assuming that at the end it's at 0 meters, at the beginning it's 40. Velocity when it hits the ground. Okay, I'm going to put a star by the one we're trying to find. Final velocity. Okay, what else? We've got VO is 0. That's based on just dropped. Okay, it's not thrown up or down. The other thing actually you want to put in here is the acceleration. I usually just throw that in the middle. Negative 9.8, because that's happening the whole time as it's falling. Okay, and then it hits the ground with some speed. All right, so it seems like maybe we don't have enough information, but let's look at it. This is what you're going to want to do, write out your equations. I'm going to go through and put boxes around the variables that I know, that I have a value for. So x0. And actually, if there's 0, I'm just going to cross them off over here too. So, but x0, I'm going to circle that, or put a box on it. V0 is 0, so I actually can just cross those ones off. A, I know that, put a box on it, here and here. X of t is just 0, and that's going to be a 0 right there. And the thing we're looking for is Vf, so I can star that. All right, so looking at this, we can't solve this because I don't know that and I don't know that. Okay, looking at this, the only thing I don't know in this whole thing is t. So I can actually solve this for t. So let's plug into this one and get t. And then I can take my t and put it here to get Vf. That will be my process. Okay, here we go. X of t is 0. X0 is the 40. This is gone because VO is just 0. Plus 1/2. A is negative 9.8 meters per second squared. And t squared. All right, keep solving this for t. I'll minus the 40 over to the other side. Okay, 1/2 times 9.8 is negative 4.9. Divide each side by negative 4.9 meters per second squared. Okay, that'll give me t squared. So I just pull up a calculator here. So I'm doing 40 divided by 4.9. 8.16. Let's use 2 decimals there. Don't quite round it off yet. I mean, it's going to wind up being meter squared per second squared with the units. But then we square root that. So square root that. I'm getting 2.857. I'm going to stay with 2 decimals because I'm not done yet. Meter per second. Okay. Oops, actually it's seconds. Somehow my units did get screwed up here. The meter should have canceled here. This is just seconds squared actually. So when you square root it, it turns to seconds. Okay, which makes sense, it's time. Okay, now we'll go to the second equation because we're actually trying to find this VF equals V0. V0 is gone. I don't even need to worry about that. Equals AT. Okay. So the A was negative 9.8. And the time I just figured out here was 2.86 seconds. Okay, so multiply that out. 9.8 negative times 2.86 is, I get 28.0. I'll round that off to 1 decimal place since it's the final answer. And it's meters per second. That's my VF. Okay, so it's a little process there of using both equations. Let's do one more example. And I'll tell you what, your assignment for this won't be due until Wednesday because they are a little more involved, obviously. So I'll give you an extra day to get that assignment done. Okay, so a car accelerates from rest to 50 meters per second in 5 seconds. What's the displacement? Again, you need to draw this out. You just try to think about it and figure it out. It's quite difficult. Fill in those same variables. Remember we did x0, v0. We put the a in the middle. I think we did x of t here. We did vf. And what was the other one? T. Okay, these are all the different variables you could have. Do this every time. Fill them in. Okay, from rest. That's a clue. V0 is 0. My starting position actually is 0 too. That's, you know, assuming we're starting from position 0. 50 meters per second. That's my ending velocity, final velocity. 5 seconds is obviously the time it took. What displacement? So we're talking displacement's the position. So put a star by that one. That's what we're trying to figure out. I don't think they tell us the acceleration either, so we don't really know that. So let's go ahead and write out our equations and do that same thing. VF equals VO plus AT, and then x of t, x0 plus V0t plus a half AT squared. I'm going to do the same things. Cross off the zeros. Boom. Boom. That whole thing's gone. Boom. Gone. A, we don't know. X of t, that's what we're looking for. I'll put a star by that. VF, we know that. Put a box on that. T, we know. Put a box on that. Put a box on it here too. Okay. So if you look at here, this, the only variable left is A, so that's a good sign. We can solve that for A. Here we can't really do anything because we don't know that and we don't know that. All right, so let's go with this one. Again, the V0 is gone. Okay, so plug in 50. A, we don't know. T was 5 seconds. That's a pretty simple equation to solve. A is 10, right? 50 divided by 5. Okay, that's not the answer. That's at least the first step. Okay, now we know A. So if you look here, we have everything we need to find x of t. It's going to just be, this is gone, 1/2 AT squared. Okay, so we're really doing at time 5, you could say x of 5, 1/2 times 10 meters per second squared times the time, which was 5 seconds squared. Okay. 1/2 times 5 is 5. 5 times 25, it looks like we're getting 125 meters for the position at 5 seconds, which is what we were looking for, right? How far did it go? So at the end, it wound up at 125. What displacement? Okay, that would be 125 meters. Okay, so it's a matter of, combining both those equations together. Do turn in a copy of these notes for points along with your assignment, which this assignment will be due Wednesday. I'll probably add a little, what do you call them, concept builder thing to work on tomorrow too, but both those things won't be due till Wednesday. Okay, so get a hold of me if you do have a question or if you want to meet about this.